Hello guys, I am Ajman and today we'll be solving the fast papers mock S1 paper. So our first question we have two fair dice that are thrown and the numbers obtained are noted. So X is the score on the first die and Y is the score on the second die. Okay, so event A. So event A is the product. Event A is that the product of the numbers is 4. Is a multiple of 4. Okay, so let us draw up the table for event A. So let us write the x and y first. So let this be x, and these are the values of the die, and these are the y values, and the product. All right, so this is event A, the products, and let us see which numbers are multiples of 4. So we have 4, 8, 12. So over here 12 and 8 here. All of them are multiples of 12 in this row, since 4 is a factor. Same for this column. And over here we have 12 and 36. So yeah, that seems to be it. Yeah, so so multiples of 4, how many do we have? 1 2 3 4 5. 5 plus 6 11, 12 13 4 and 15. So we have 15 multiples of 4. And now the event, so now let's think of the second event. Event B is that x is greater than y. So let's make a table for that too. So this is event A, 15 of them, 15 out of 36. And event B, x is greater than y. So 1 2 3 4 5 6, 1 2 3 4 5 6. So again the same thing, but x, so this is, let this be x and this one be y. So x is bigger. So in this case 2 is bigger. Yeah, so this entire row, and over here 3 is bigger, so this one's, and just like that, this pattern is just simply like this, and 6. So these will be all the numbers to the right over here. So how many numbers do we have? We have 1 here, 1 number here, 2 here, 3 here, 4 here, and 5 here. So that's 6 6 12, 12 plus 3 15. Again we have 15 numbers. Okay, so determine whether events A and B are dependent or independent. Two events are independent when two events are independent when the product of them, P of A into P of B in this case, are equal to the probability of the intersection. So basically if we multiply these two probabilities, if it is equal to the intersection, so that means that we have to check if both of them are true at the same time, then we will know their independence. How do we check the P intersection of A and B? We just simply see where both of these are true at the same time. So we'll have to check just we can see the line here. We just have to check these numbers. So everything above this Oh yeah, this part. Yeah, this number should have been skipped. Yeah, so all this now, let me redraw it with another color. So all of this, all the numbers above this line, I'm just redrawing this line over here. So those are 1 2 3 4 5 6. Again 1 2 3 4 5 6. Yeah, so 6. So p, the intersection of probability of a intersection b is 6 by 36. Okay, now let's multiply these two numbers. 15 by 15 into so let us simplify this. So this can be simplified to both of them going to divide by 3, so 5, and this one would be 6, sorry, 12 divided by 3. So this one is the same thing, 5 by 12, which equals 25 by 144, and this one is 1 by 6, and we can check in the calculator, but these two will not be equal. So since they're not equal, that means they're not independent. So in our next question, we have a back-to-back stem and leaf diagram. So in our next question, we have a back-to-back stem and leaf diagram, and which is the reaction speeds in seconds of two groups, group A and group B. So over here we have the reaction times. I need to find the median and the interquartile range. So first let's count how many people there are. So there are 5 to 15, 15 plus 7, so that's 22. And so 22 people in group A, and over here we have 6, 16, 16 plus 6, 22. Again 22 people here. So the median, since they are even, so they can be divided into groups of 11 and 11 people. The median will be the average of the 11th person and the 12th person. So this will be 10. So this is the 11th person and this is the 12th person. And so in this case, that's 3, 5, sorry, so 3, 5, 8, 9, 10, 11. So yeah, 11th and 12th person. So let us find the median. So using the key over here, 22, 5 means 0.225. So this will mean 0.220 plus 0.222, and the median is 0.221 for group A, and for group B same thing, 0.226 plus 0.227 by 2 equals to 0.2265, which is approximately equal to 0.227. So these are the medians. So for the interquartile range, you have to find Q1 first. So since it's 11 people, it can be 11. So half of the group is 11, right? And we'll divide this again in two groups. So this can be divided into 5 people, 1 person, and then again 5 people. So the median of this half group is the 6th person. So the 6th person is 0.221. Sorry, 212. Yeah, so 212. So this is the Q1, and the Q2 again, it will be the 6th person in the second half, the second 11 people. So let us go backward. So 1 2 3 4 5 6. So this is the 6th person from the back. So that is 0.233. Yeah, so yeah, that's it. That will be the range. So we get 0.021. Yeah, so that is IQR1A. And for the second person, so same thing again, we divide in two groups and then we get 5 5 6 1. So the 6th person again here, so this will be this, the 6th person on the back, it's this. So let us do the same calculation again, 0.235 minus 0.215, and this is equals to 0.020. So yeah, so that this is the interval range for group B. So next we are asked to draw a box and whisker diagram. So what are the things we need? We need the maximum number and minimum numbers. So for group A, let me note down here, the group A, the minimum is 0.200, and for group B it is this is A, and let this be B, The minimum is 0.203, and the maximum for group A is 0.246, and the maximum over here is 0.247. All right, so we have the medians, the Q1 also. We also have the Q1, yeah, so we have everything we need. So since the maximum is 4.7 and the minimum is 0.2, we can start at 0.200 and end at, so each of this division can be 10. So yeah, so each of this, let it be 210. Yeah, then we can represent 3 here as a third box. Yeah, so giving this division, we have 0.220 here, 0.230, 0.240, and 0.250. So yeah, that we can cover the maximum. So let us do A first. 200, so exactly over here. So A starts, let it be this line. So this is the minimum, and then the Q1. The Q1 is 212. So 212. So this will be the minimum. So we're connecting those two, and then the median. The median was 221. So it's this line, and the maximum is 233, which is this. Yeah, so next we just simply connect them. Oh no, I meant that's the Q4. Yeah, so the maximum is 247, so which is over here. So yeah, minimum, maximum, Q1, Q3, and the median. Okay, so that's group A. And for B, the minimum, this one starts at 0.3. So over here is this line, and then the Q1 is 215. So yeah, in the center here, and the median is 227. So this, and Q3 235. So this, and then it ends at, the maximum is 247. Yeah, 247. Actually, the maximum here was 246. Now that okay, so it should be here. So yeah, that's it. So here we have our first difficult question. So factory produces microchips, and historically the probability that a single microchip is defective is 0.05, and the chips are packed in boxes of 20. To ensure the quality, each box undergoes a two-stage inspection process. So we have boxes which have 20 microchips, and the probability of being defective is 0.05. Okay, so accepted. So the number of defective chips in box X is determined. So if X is less than equals to 1, so that means the number of defective is less than equals to 1, and then it's accepted. If it's greater than equals to 3, it's rejected. And if it's equals to 2, there's a stage 2, more testing. So in the stage 2, the 5 of the chips are randomly selected without displacement. And if any of those 5 chicks are 5 are, so if any of these 5 chicks are selected to be founded with, then the box is rejected. So basically from the 20, so first we did a test of the 20 boxes. They see how many is defective. If it's less than 1, then it's accepted. If it's greater than 3, so we have 3 or more defective microchips, it's rejected. And in the case of the exactly two defective microchips, there's a stage 2. So what happens in stage 2? We have 20 microchips, right? So among them, randomly 5 are selected, and they're again checked if they're defective or not. If none of them are defective, is there no defect in any of these 5, then it is accepted. But if any of the 5 microchips are defective, then it's rejected. All right, so let's do the first question. Calculate the probability the randomly chosen box is rejected. So how can a box be rejected? We have two cases that the first one is x is greater than equals to 3, and the other one is x is greater equals to 2, and then again in stage 2 it fails. So first case is a bit easier, so let's start with that. So we have it's a binomial probability, because the cases are that it can either be rejected or accepted, or sorry, it's either defective or not defective. So it's a binomial case, and since it's 20, the power is 20. So we're going to use binomial with probability of 0.05 plus 0.95 and to the power 20. So over here the question is like 3 or more. So that means 3 or more are defective. So the easier way to do it would be that we subtract from 1 the cases where x is equals to 0 or 1 or 2. So that way it's because if you do 3 or greater, we have to add from 3 to 20, right? So instead we just subtract from 1 the cases when x is equals to 0, 1 or 2. So let us do that. So 1 minus, so the case when there's 0 defective, so in that case is 0.95 to the power 20. All right, then it's we have 1 defective, so it's 20c1 into 0.95 to the power 19 into 0.05 plus, okay, we can just put the whole thing in bracket, yeah, so 20c2 0.95 to the power 18 into 0.05 square, and this is equals to 0.0754. All right, so this is our first case, p is greater than or equals to 2, and our second case, if it is exactly equals to 2, in that case let us first find the probability of it being exactly equals to 2. So the probability of that case is it's just simply this one. So that is, let us use the calculator. 20c2 into 0.95 to the power 18 into 0.05 square, and that's let me write it here again. P of x equals to 2, 0.18867 68, round it up. All right, so this is the probability of it being that the case that there's exactly 2 that's except 2 that's 2 that's defective. All right, so in that case we're going to go to case 2, right? So in stage 2 we have, if we want this to be accepted, so if we want this to be rejected, the case can be that there's like 5 microchips, either 1 is defective or 2 or 3 or 4 or 5. So that's too many cases, right? Again, just like the how we subtracted, we use the opposite case. We from 1 we subtract the case, from 1 we subtract the case that all of them are good, so there's no defect, so all 5 of the microchips are good. So how do we do that? We get the probability. So the probability of choosing only choosing the non-defective microchips, we have 2 exactly, right? 2 exactly defective microchips, so the probability of choosing all 5 are good, so all 5 are non-defective microchips. So in this case we are there. So why is this like this? Because we have 20 microchips, and from there we are choosing 5 of them, right? And we know that there's 2 defective microchips. So in this case we're taking the case that we're not choosing those 2 microchips, and however or we're choosing so this part covers all possibilities. So we have 20 microchips, and we're getting five random microchips. So this cover all cases, and these are the cases which are where we are not choosing the defective microchips. So if you subtract that, we get all the cases. So these basically represent the case where none of the microchips are defective, and if you subtract from one, we get all the cases when there's 1 defective microchip or 2 or 3 or 4 or 5. So this is equals to 0.4474. So now we add all of this up. So we gotta multiply these two numbers, by the way, because first we have this case and then we multiply with this case. So this becomes, we have this answer, so 0.0754. So this is 3 or more are 3 or more are, So 3 or more, so rejection, and we get the case of we have two rejections, two defective. So these 3 or more defective and this 2 defective into, and we get the multiplication from the second case, second stage. So 0.4474, and then that gives us our final answer, 0.1598. This is a very difficult question. Try it out again. You will hopefully understand it as you try it out, as you solve this following the mark scheme. So in this case, we have a large shipment consisting of 140 boxes. So you use a suitable approximation to find the probability that at least 120 of these boxes are accepted. So going back to the previous question, we have two cases, right? Accepted or rejected, and we know the probability of getting rejected. So if this is the probability of a box getting rejected, since it can be either rejected or accepted, the probability of a box getting accepted is 1 minus this number, 0.1598, and that gives us 0.8402. So we have 140 boxes that can be accepted, right? Sorry, we have total 140 boxes, right? And since since these are discrete numbers of 122, we can use the binomial distribution easily, right? So you can use this is following the binomial distribution, but since the number is big, we can easily use a normal approximation. Since they're asking us to use an approximation, we can since binomial distribution with large numbers approximates the normal distribution, we can use that. Sorry, the normal distribution approximates the binomial distribution, we can use that. So let us do that. So first we need to find out the mean. So the mu the mean, and that's NP. So we have 140 boxes into 0.8402, and that gives us 11763. And then the variance which is NPQ, which is 140 into 0.8402, which is this number, and probability of accepted, and then the probability of rejected, which is just this number, 0.1598, and this gives us 18.79. And the variance, since we want the variance, so since we want the standard deviation, we can just square root this and we get 4.335. And now when we're doing a binomial distribution with normal approximation, since it's greater than equals to 120, we need a continuity correction, right? So since it's greater than equals to 120, so we can simply write it as greater than 119.5, because that will cover the case when it's 120 also. So p of y greater than equals to 120 is the same as p of p of y is in the normal distribution greater than 1195.5. Okay, so now let us find the z-score. So z-score is the value we got. Where is it? Oh yeah, so sorry, the mean. So yeah, first the mean. The mean is 117.63, and we will subtract this from the value, right? This value. So 119.5, just using the standard formula, and then we divide it by the variance, and this will give us a z value of 0.431. So what we're looking for, we're looking for p when the z value is greater than 0.431. And if you want to use the table is so using the table, we can just reverse this. So 1 minus p of z less than 0.431. So this is equals to, now we can use this table, so phi 0.431 equals to 1 minus, and we get this value from the calculator or using the table, 6667, and we get 0.333. Yeah, so that's it. So this is the final answer. So in this question, we have rowing club, which has two squads: the racing squad with 15 members and the development squad with 25 members. For the racing squad, the mean weight is 82 kgs, standard deviation 4.5. And for the development squad, the sum of y is 1900 and the sum of y square is 14,005, 1,45,500. So where W is the weight of the member in kilograms. Okay, so we need to first find the weight, mean weight of all 40 members. So first we need the sum of all the weights. So here we have 1900 easily for the second case. So which is the sum of all the weights of development squad. For the racing squad we have the mean. So using the mean we just simply multiply with the number of members, which is 15. Which 15 is given here, and then we get 1230. So and then simply add 1230 with this 1900. So this is the sum of all the weights of all the racing squad members, and this is the sum of all the weights of all the development squad members, and then we divide by the total number of people. So 15 plus 25, 15 plus 25, and we get 78.25. Then they asked us to find the standard deviation of the weight of all 40 members. All right, so we need to use the formula. So the formula over here for the standard deviation, we can use this version. So STD is equals to the square root of sum of x square by n minus the mean x square. So this is the formula from the formula sheet. So in the first case we have standard deviation of 4.5. So we can just square this side, is easier to use. So a square and then the x square. So the sum of x square, we don't have that. So we are trying to find the sum of x square. Since we are going to find the standard deviation of all them, this is exactly what we're trying to find in this case. So n is 15 minus the mean square. The mean is 82. So 82 squared. And when you solve this, we get the sum of x squares, which is 101163.75. Then we combine the x square and y squares to get the square sums of all the weights, and then we can divide this by the mean. Sorry, by the total number of people. So which is 15 plus 25. So again, we're just using this formula here. Okay, so the standard deviation formula. So over here we are summing the x's and the y's together because these are the combined squares, and then we're going to subtract the mean. So the mean of the combined group is 78.25, 78.25 square, and this comes up to let us replace the numbers. So we have 101163.75 plus sum of y squares, which is 14,500. Okay, I think it's 20. Yeah, and then divide by 40 minus the combined mean squared, and this gives us 6.60 kg. So that is the standard deviation of weights of all 40 members. So this question is a bit straightforward related compared to the others. Now this one is a very difficult question. Only one person could answer this in the exam. So over here we have a red spinner with 4 sides. So a red spinner with 4 sides, 1, 2, 4, 6 numbered, and a fair blue spinner. So a blue spinner with 3 sides, numbered 1 to 3, and a fair green spinner with 2 sides, 1 and 2. When a spinner is spun, the score is the number on the side on which it lands. The spinners are spun at the same time, and the random variable x denotes the product of the 3 spinners. So all of this R, B, and G, they are multiplied, and the product is the score is a product. So how do we do this? So if you think about this, you have seen questions with R into B, right? So 2 spinners, R in B. So you draw a table, right? But over here we have a third spinner. So if you try to draw a table, it will be a 3D table. So over here we have a scores of R and B, and over here we can multiply with G. So all the scores, but that seems complicated first. but then you notice that the number of sides for the last spinner is just only 2, right? So this side was the 2 sides. So in case we can think of this as, we can slice this cube into 2 squares basically. So square 1, square 1. So this square is for when the green spinner is just 1, and this is for when green spinner is 2. So this might not make much sense now, so but later let me show how we do this, so it will make sense. So over here, so since R and B are the bigger size, we're gonna make them the base. So let us do that. So first, the red spinners, they are numbered 1, 2, 4, and 6, and this blue spinner with 3 sides are numbered 1, 2, 3, and their number, so their product is 1, 2, 4, 6, 2, 3, 2 to the 4, 4 to the 8, 6 to the 12, 3 to the 6, 4 3 is the 12, 6 3 is the 18. So this is the first box. Why? Because the G of, we have two G values, right? 1 and 2. We can say the G is 1. So we can think of this as this first one, and the second one is this. So basically, since there are two different sides, we can break up this cube into two boxes like this, 1 and 2. So I just did for, so first one I did when green is 1, and then for the second one we simply multiply this table with 2, or everything by 2. So we get 2, 4, 8, 12, 4, 8, 16, 24, 9, 18, 24, and 36. So basically this is when green is 2. So basically it's the same thing, 1, 2, 4, 6, 1, 2, 3. I just didn't write them to save time. So this for when green is 1, this is for green is 2. To summarize what I did here again, so this problem, normally we see R cross B, right? So R cross B, but this problem has another spinner, a third spinner, which means the problem 3D, which makes it hard. So drawing a 3D cube, but then we can slice up the cube, right? So we can make it into 2 slices, because since this side is 2, we can just so let's say this is green, so this is red, so it's 4, and this is blue 3, and the green side, since there's 2, we can slice it up into two boxes, 2 squares easily, so 1 and 2. So that is what we did. So this is the first square with 1, and this is the second square. Since over here we're multiplying with 1, it's the same thing, we don't have to multiply with it, we just multiply R into B and into 1. And for the second slide, we simply take this product and just multiply it with 2. So these are the 2 slices. And now we have all the numbers we need. So we have, what are the numbers we have? X can be, from here we can see it can be 1, 2, 3, 4. I'm just listing all possible values from here. It cannot be 5, it can be 6, 8, 12, 16, 18, 24, and 36. All right, so now from the table we will just see which number, so what's the probability. So how many number possibilities is there? So there's like 1 2 3 4 5 6, 3 into 4, so that's 12, and 12 into 2 is 44. So there are 24 possibilities, so the probability will be out of 24. So how many ways can we get one way? Only one way. How many ways can we get 2? So we have, how many 2s we have? 1, 2, and 3, so 3 2s, and 3 only one way, so 1 by 24. Same thing for all the number, I just checking how many numbers there. So like for 4, 1 2 3 4, so there are 4 4. So just like that, I'll just fill up the table. So yeah, that's it. So this is the probability distribution. It's a very difficult question, again only just one person could answer this. So now let's go to the next question. So over here we have to find out the variance of this probability distribution. So first let's write the formula of the variance for a discrete random variable. So variance of x is equals to expectation of x square minus expectation of x. So this can again be rewritten as so this is the formula given the formula sheet, sum of x square p. So this is the expectation of the x square minus just the same thing again. E of x, expectation of x, squaring this. So let us find all this individually. So first, what we need to find is the x square p. So expectation of x, so x square p, this term. So that's 1 square into 1 by 24. Okay, so basically everything will be 24 out of 24 when you do the sum. So let's keep everything over 24. So first is 1 square into 1, then 2 square into 3. So that's 4 into 3 plus 9 into 3 square into 1, 9 into 1 plus 4 square into 4, so 16 into 4 plus 6 square into 3, 36 into 3 plus, and on it goes. So just like this, I'm just squaring this and multiplying with this, and when we do this sum we will get 166.25. All right, so this is the x expectation of x square, and sorry we will get, yeah, that is correct, we will get this 166.25. And when we try to find out the expectation of x, so we need this also, right? So what we do is the same thing, just this time just multiplying these two instead of adding. Again we have everything over 24, so 1 into 1, so that's 1, 2 into 3, so that's 6, 3 into 1, so that's 3, 4 into 4, that's 16, plus, and on everything, so just like that. And then we add them all up and we get 9.75. So so now we apply this formula, 166.25 minus 9.75 square, and we get 71.1875. So this question is a bit straightforward. Find the probability that x is a multiple of 6 given that x is a multiple of 4. So given, so over here the denominator we know that it will give, it is a multiple of 4, and over here that we find the probability that x is a multiple of 6. So it's a multiple of 6 and we know it's also multiple of 4 because given, that means it's 6 and 4 both. So 6 and 4 both. So first let us find out the numbers which are a multiple of 4. So we have over here 1 2 3, 1 2 3 4 5 6 7 8 9 10 11 and 12 13. So the numbers for the radians, so there, these two was wrong. So 3 2s is 6, 3 2s is 6, and 6 2s is 12. So there's actually other one, 12. Also I missed this. So the total is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So 15. So so the probability of being 4 is 15 out of 24, and the probability of being a multiple of 6 and 4 is, so it has to be both of 6 and 4. So among the circled ones we have this number 12. So 1 2 3 4 5 6 7. So 7 numbers that are both a multiple of 4 and 12, so 7 by 24. So that's that gives us simply 7 by 15. Another way you can think of it is that like choose all the 4s and then among them just see how many 6s there are. So we have 4s. How many 4s do we have? We have 15 4s. So among them, how many are also multiple of 6? 7 of them. So both of them, both reasoning works. So yeah, that's it. Just simply 7 by 15. So first question, we have 11 cars, each of a different color, are to be arranged in a line. The 11 cards include a red card, a neon card, and a cyan card. How many different arrangements do not have the red card next to the cyan card? So this one's pretty simple. We first it says arrangement, right? So it's permutation question, not a combination question. So what we do is we do not want them next to each other. So first we put everything together. So we first find all possibilities, so 11 factorial, and then we subtract out the cases when they are together. So when is that cases? So let's group them together. So red and red and cyan, we let this be one group together, and it can also be CR, so two possibilities. So there are two possibilities, and since they're together, so we have 10, we have 9 cards and this group, right? So total 10. So it's 10, 9 plus 1, so we have total 10, and then we can arrange them in a line. So that's 10 factorial, and this gives us 32, 659, 200. So in this case, we have how many different color arrangements can be made if none of the three colors, red, cyan, or neon, can be next to each other. So in this case, we cannot use the subtractive method because it's for three colors, and that's too many cases. We can actually use it, but it's just too complicated. So the simple way would be to use just take out these three colors, red, neon, cyan, and if we do that, we have 11 colors, right? So we have 8 colors remaining. Arrange them. So we arrange the 8 colors, 1, 2, 3, 4, 5, 6, 7, 8, and then in the holes, in between the holes, place them. Place the 3 cards anywhere in these holes, and that will make sure that they are never next to each other. So this method gives us, first of all, 8 factorial, placing these 8 cards, and then into we have the gaps. So we have 9 gaps, right? So 9 gaps, and among them we choose 3 randomly. So 3, and after choosing them, since we're using combination over here, we also multiply by the 3 factorial to because we're just choosing anything randomly. So RNC and NCR, they would be the same thing. So we're also multiplying with 3 factorial, so we can it also accounts for the different arrangements, and then doing this we get 23,21280. So in this question, we are taking consider all possible choices of 4 cards from 11 cards. So amongst the 11 cards, we're taking 4 cards, and the 4 cards are arranged in a line. How many different arrangements of 4 cards do not have the red card next to the cyan card? So red card and then a cyan card. So this is kind of the first question, except this time first we are taking 4 cards and then doing the same thing. So it will pretty much be like the first question. So first we use 11p4. So this will get us all possible arrangements of all possible 4 cards among the 11, and then from that we will subtract out cases where the red and cyan are next to each other. So first we can choose 2, because let us assume we already chose red and cyan, so we already chose 2. Now we have 2 remaining to choose. So let us choose 9c2. So those are the remaining cards, and so we're choosing them, and then we multiply that with so among this, right, we have R and C, right? So this is a group. So we're chosen 2 cards, and we have one group here. So we have 1 card, 2 card, and this group. So we chose this one 2 from this. So now we will arrange them. So since it's grouped together, we have 3 items really. So we can rearrange them in 3 factorial ways, 3 items. And since R and C, it will also be CR, right? We can rearrange these two. So in that we can do that in 2 factorial ways. And so doing this, so basically we took all possible cases and subtracting the case when red and cyan are together, and then we get 77488. In this question we have that during the school days, each day Rashid rides either on his bicycle with a probability of 0.73, or his scooter with a probability of 2.1, or on his skateboard. So Rashid rides. So first thing, since we know the scooter and bicycle, or so this is the last case, we can easily find out the probability of skate by subtracting the probability of scooter, so bicycle first and then scooter, and we get the probability of him riding the skateboard 0.06. Since these are the only 3 possible cases, Rashid only rides in one of them each day. If he rides on his bicycle, the probability that he hurts himself is 0.15, and for a scooter is 0.32, and for a skateboard is 0.82. Find the probability that Rashid hurts himself on any particular day. This is very straightforward. I just take the probability of him riding the bicycle, multiply that with him getting hurt while he rides on his bicycle. So 0.15, probability of him riding a scooter, which is 0.21, and then him getting hurt, so 0.32, and for the skateboard 0.06 into 0.82, and this gives us 0.2259. Pretty straightforward. So this question asks us that given that Rashid hurts himself on a particular day, find the probability that he's riding on a skateboard. So basically what the probability that he's riding is on a skateboard, given that he hurt himself. So how do we do that with the formula? So probability of both of them happening, him riding his skateboard and getting hurt, by him riding the him getting hurt. We are by the probability of him getting hurt. So how do we get? We can just use the previous question answer. So over here we already calculated this 0.0. So this is the probability of him getting hurt and him riding his skateboard and getting hurt, which is 0.06 into 0.82, and then over the probability of him getting hurt, which is 0.2259, and this gives us 0.218. So over here, find the probability that Rashid rides on a skateboard on at least 4 of 12 randomly chosen days on a holidays. So 4 of 12 randomly chosen holidays, and since he can either ride a skateboard or not ride a skateboard, and we have the specified number of cases, simply binomial. So what's the probability of riding a skateboard? 0.06. So 0.06 plus 0.94 to the power 12. Okay, so at least 4 of the 12 days, 4 or more, right? So instead of doing that, instead of counting from 4, 5, 6, like just like that previous question, we count for we subtract one represents the entire probability. So from that we subtract the cases of him reading 0, 1, 2 or 3 days. So yeah, so that's, let's do that. So him writing 0 days, so that's 0.94 to the power 12 minus, and for 1 day it's 12, so 12c1, so 12 into 0.94 to the power 11 into 0.06. So this is him writing only 1 day, minus 12c2, so 12c2 into 0.994 to the power 10 into 0.06 square minus 12c3 into 0.94 to the power 9 into 0.06 cube. So yeah, that gives us 0.00434. So that is the answer. So in this question, let a Pn be the probability that the first day Rashid rides his skateboard is on the nth day of the holidays. Find the total probability that the first day Rashid rides his skateboard is before the 5th day. So this one, it's a geometry distribution because it has a number of trials. It has a Bernoulli distribution, and so each of these trials doesn't affect the day because the probability resets every day. So what is the probability of riding a skateboard? Is 0.06, just like the last question. 0.06, and the probability of him not riding is 0.094. all right, so the probability that he rides his skateboard before the 5th day. Okay, so he rides on the 0th day, 1st, 2nd day, 3rd, 4th. We could simply subtract it from 1. We subtract from 1 the case that he doesn't ride his skateboard for 4 days straight, so that the probability that would be 0.94 to the power 4. So we're taking the case that he doesn't ride his skateboard for 4 days straight. So that would be the case, that would be the opposite of the case that he rides before the 5th day, and then we subtract that from 1, and then we should get this answer. So this would give us 0.219. So yeah, that's it. Thank you for your time. Good luck for the exam.